How often do you think about what's powering the device you're using or watching? Electricity is an innovation we take for granted, but it has an interesting and controversial past, and it's about to experience a serious disruption for the first time. Electricity has worked the same way since the late 1800s when Tesla and Edison battled it out in the War of the Currents. While the two started as colleagues, an epic rivalry formed between them. Edison championed DC as a prevailing method for electrical distribution, while Tesla saw the potential of AC. In 1893, a massive World's Fair in Chicago was illuminated by 160,000 AC light bulbs. It was so impressive, especially in such a dimly lit world, that it put an end to the dispute and made AC power the winner. More than 130 years later, we still use AC power, and it still works the same way. But consider the technology we use today that still relies on traditional electricity. After more than a century, isn't it time for electricity to change so it can keep up? The industry agrees, a transformation is needed. Everything we do relies on electricity, and our dependence on it is only getting stronger. That's why fault-managed power systems were born. These systems enable power to be faster, more flexible, more manageable, more controllable, and safer than conventional electricity. They're also much easier to deploy, which can significantly reduce project costs and allow fast device setup and powering. Unlike conventional electricity distribution, the inherent safety of fault-managed power systems means that they can be installed using low-voltage installation practices. Fault-managed power also minimizes electrical hazards. With current electrical distribution, several safety protections are needed to protect users. But even with these protections in place, current electrical distribution is still dangerous. Fault-managed power detects, reacts, and protects against these fault conditions, ensuring safe operation and failure modes. In other words, it eliminates the electrical hazards associated with traditional distribution. Fault-managed power systems are safe because they constantly monitor for faults and control the delivery of electrical current during the normal condition. This mitigates the risk of shock or fire that often occurs with conventional electricity. Historically, to keep people from getting hurt, entire organizations and sets of standards have been necessary to provide guidelines on how to safely work with electricity. Here's why. First, traditional electricity operates at high voltages that aren't safe to touch without protection. We refer to human touch from one power conductor to another power conductor as a touch fault. When voltage meets the human body, the electrical current can disrupt a normal heartbeat, leading to cardiac fibrillation. At very high currents, you can experience harmful burns. Another concern is conventional electricity's ability to take an unintentional and often dangerous path to ground, which means it doesn't always go where it's expected, damaging property or hurting people. This is called a ground fault. An arc fault is yet another safety factor. If you've heard a light switch or outlet buzz or hiss, then you've heard an arc fault. Much like a car speeding down a road, electrical current doesn't like to stop once it's flowing. Electrical current jumps through the air between the wire ends so it can keep moving when a wire is loose or disconnected. This forms a very high temperature electrical arc that can reach thousands of degrees Fahrenheit, burning people or starting a fire. There are a few other types of faults to be aware of with traditional electricity too. When too many devices are plugged into the same circuit, the current can increase beyond the wire's design rating. This is called an overcurrent fault. Drawing more current through a wire than it's designed to handle overheats the wire and can cause a fire. The most common cause of electrical fire fatalities at home is a fault called a resistive fault. It's usually caused by a poor connection or broken wire strands. The series resistance of a circuit rises above its design rating and heats up the conductors, potentially causing a fire. To protect against these hazards, the industry created 3 safety technologies over the years. Number 1, circuit breakers to protect wires and devices from catching on fire due to an overcurrent fault. Number 2, GFCI, or ground fault circuit interrupter outlets, the ones you see in bathrooms and kitchens to shut off power when electricity takes an unplanned path to ground during a ground fault, including through the human body. And number 3, arc fault circuit interrupters, or AFCIs, which break the circuit when an arc fault is detected. Fault-managed power addresses the electrical hazards typically managed by breakers, GFCIs, and ACFIs in conventional distribution systems. That's the magic of this new technology. Traditional power systems can't detect touch faults or resistive faults. This is only possible with a fault-managed power system. The system can also detect line-to-line faults. In other words, they can tell the difference between a human touching the wires and the load. No other technology can make this distinction. Some fault-managed power systems can even detect the series resistive faults that result from loose connections. Digital electricity created by VoltServer is a type of fault-managed power system. It makes electricity easier to work with and safer to touch so the world can more quickly deploy new technology. It's faster to install and can be less expensive than conventional electricity, enabling a completely new way to distribute power. Here's how it works. Digital electricity splits electricity into small, safe packets. Every second, hundreds of energy packets are sent from a transmitter to a receiver. During this process, the packets are monitored for safety. If a problem arises that could cause a safety issue, then the system stops sending packets. Digital electricity is distributed with flexible, small-gauge, lightweight cables following low-voltage installation practices. Depending on your jurisdiction, this means it can be installed by electricians, IT integrators, low-voltage contractors, or even in-house technicians once they've been properly trained. The technology is already being used in hundreds of airports, offices, hotels, stadiums, schools, and manufacturing plants around the world to save money and time, reduce project complexity, and save energy. The benefits of fault-managed power systems, such as digital electricity, come down to the 5 S's. First, digital electricity, or DE, provides the power associated with an AC wall outlet and is compatible with today's digitally connected world. Although it can be used for short distances, it can also carry electricity across long distances to get the power in remote locations. It's faster and more cost-effective to install than traditional power distribution systems, offering the safety, flexibility, and installation speed of a common USB cable. Because it uses small-diameter, lightweight cables and small conductors, it saves space and reduces costs and materials compared to traditional power systems. Data can also be transmitted on the same conductors as digital electricity. Other types of communications conductors or fiber optics can be integrated into the same cable as digital electricity as well. Combining data and power in the same physical channel saves even more space and further reduces costs, and it's only possible with digital electricity, not AC power. To ensure safety, digital electricity stops hazardous current within milliseconds to prevent hazards to people or damage to property. And finally, it's fast to deploy. People don't have to be relocated during installation. Permits may not even be required, and in-house IT teams can add new technology and complete moves, adds, and changes easily. The 2023 version of the National Electric Code adopts UL 1400 and introduces fault-managed power for the first time. It's unique and specialized enough that it calls for its own code section. The new Class 4 classification standard was created especially for fault-managed power systems. As the creator of digital electricity, VoltServer is one of the first to work on developing and commercializing a Class 4 system that reinvents how electricity is distributed. As the need for power and connectivity continue to increase, many industry experts believe that fault-managed power systems will overtake conventional electricity as the primary distribution infrastructure for intelligent buildings, wireless densification, data centers, EV charging, and even agriculture environments. Volt Server is empowering the future of electricity distribution through digital innovation, and the future has never been more exciting.